Okay, so good morning, everyone. I hope everyone has joined the meeting. Ask your friend also to join as soon as possible. We are going to start within 2 minutes. So join as soon as possible so we can start. We will first start with the discussing the homework problem and then we will be proceed further. Okay, so we are starting. This is our homework problem. We have to calculate the force on this charge. So basically, for calculating the force on this charge, we have seen that this is a positive charge, so it will try to repel in this direction with a force of F1, which is written as K, Q, Q. And as I mentioned, this is a equilateral triangle. You can consider the side of a triangle as A. So the distance is A square. That is a force F1. Now, if we see the force F2, this is a negative charge, so it will try to attract this charge toward itself. And this force will be written as F2, which is equal to K, Q, Q by A square. Remember that we are not considering minus sign here. Why? Because the direction is considered, so there is no need to consider the minus sign. And the angle between them is how much? If this is 60 degree, this angle will be 180 minus 60. So the angle, so we can see that there are two vectors are there like this, and the angle between them is 120 degree. And this is also F, and this is also F. So in that case, the resultant will always go from the middle, and this angle will be 60 degree. And this value will be how much is F net? So F net we can calculate by the formula of vector which I have given in the previous class. This will be F square plus F square plus 2 F square into cos 120 degree, and this value will be how much? So this thing will cancel out. You will get only F. So our net force will be F net is equal to how much? K Q square by A square. So that is the answer of the first homework question. Clear? Now we have a next another question is this one, in which I have told you that whenever there is a 3D case, whenever there is a case of 3D, we are going to use the Coulomb's law in vector form. But if we analyze this question properly, we can say we can solve it without using this vector form concept, which we have learned that whenever there is a 3D, we have seen one question also, that is a question on cube, and we have seen that how to solve it. But this question can be solved without using 3D concept. If we try to analyze it, it is something like this. If I draw for you, it will look like this. It is a square, right? It is a square. I have told you that this bottom is a square, and if you take this thing and you compress it like this, then it will look like this. Then it will somewhat look like this. There will be charge at the center, q. I'm trying to compress it. Okay, so there is a charge in the center, and these are the four corners. There is a charge at here, q, 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 and q. Now, basically, we have to calculate the force on this charge. So if you it is something look like that this charge will try to repel in this direction. This charge will try to repel in this direction. This charge will try to repel in this direction, and this charge will try to repel in this direction. So all the charges will apply a force and they all are equal and opposite. So the net force on this charge we can see is directly zero only. Okay. This is the way we can analyze by using 2D concept. But let us apply the 3D which we have seen. See, if you try to see this question in 3D, this is a charge Q, right? This is a charge Q. And if you see that all the four corners have a charge Q. So this charge Q will apply a force to this charge in this direction, right? Similarly, this charge Q will apply the force in this direction. Similarly, this charge Q will apply the force in this direction, and this charge will apply the force in this direction. Like it is like this. Like we have a four vectors in this direction, then in this direction, then this, then this. Now if you take the component of these vectors, suppose this is my point and I want to take the component. I have a four vectors like this. They are four vectors which are going like this, like a petals of a flower. We have a petals like this. Similarly it is like this. So just I am drawing one vector. So let us consider this vector. There is a one vector like this. So if you see this vector will have a two components. One is a horizontal and one is a vertical component, right? There will be one horizontal component in this direction and one vertical component. This is horizontal component and this is vertical component. Now you can see that all the horizontal, similarly another vector will be here like this. It will also have a one horizontal component and one vertical component in the same direction. So I can say that if I analyze, I can say that all the horizontal components will be cancelled out with each other. Only the vertical component are getting added. Okay, so there will be force in the vertical direction, there will be no force in the horizontal plane, and that is what we have seen in the horizontal plane. If we are solving this question, we are getting net force equal to 0. But if we want to analyze in the vertical direction in 3D, then we have to analyze in the vertical direction. And when we are analyzing in the vertical direction, we are getting a force in the upward direction. And if we want to find out this value of force, how much will it will be? It will be F sine theta, and there are the four components. Four vectors will be there because there are the four vectors. So four components will be in the upward direction. And what is the value of this? This is 4k q. How much is the charge? This is q. So it will be q square upon what is the distance between these all charges? What is the distance between all these charges? So the distance will be, if this is suppose 2a and my this distance is a, I have it is something like a triangle. You have to analyze. So this is the case. This distance, this is a square, so obviously this diagonal will be root 2a. Half of the root 2a will be a by root 2. Half of the root 2a will be a by root 2, and this height is 2a. So now you can calculate this height, right? So we can calculate this height by Pythagoras theorem. This will be almost how much? This is 2a square, 4a square plus a square by 2. So this is our distance. We can call this as d, and we can put this value here. So it will be d square sine theta. Now how to find sine theta? Sine theta you can find, this is the angle is theta, right? So it is an angle from the horizontal. Okay. So if you want to find theta, what you can do, you can extend this horizontal from here and you can draw like this. It will come out to be the center. It is the center of the square. Let me draw here. So it will be something like this. This is a square. This is a center, and we have a one vector. Okay, and this angle is theta. So we can calculate this angle, right? Because how we can calculate, if you can draw a triangle like this distance we know, this distance we also know. So you can apply the sine theta, whatever this angle is, same angle is this. So we can calculate this angle also. Okay. So this is how we can do this question. It is a little mathematical question, but yeah, you have to think according to that to solve it properly. Okay. Clear? So this is how you have to think. Clear? Any doubt is there? Please let me know if anyone have any doubt. Basically, see, this type of questions will help you to make your understanding. They are little mathematical, okay, because you have to use your concepts. Okay, how there is an approach of, if you can analyze in a horizontal ground also, vertical ground also, and then you can solve it. Okay, in spite of going into the going into the vector form. This I am telling you little complicated. Why? Because you are not applying a vector form, right? If you apply a vector form, you can write the coordinates of all, as we have told earlier, and then you can write f1, f2, f3, f4 like that separately, and then you can total add it and you will get the total answer. That is another way of doing this. Okay, clear? Now, this is an important question. How many of you have solved this question? This question, basically, in this question, I have mentioned that we have to calculate the force on the 1 coulomb charge. So let us, basically, I have told you that force is unaffected by the individual charges. So we will write the force for all the charges on this 1 coulomb charge, and then we will add it. So let us write it. So write the force. F net is what? F net is simply F1 plus F2 plus F3 plus F4, like that up to infinity. Okay, because the charges are up to infinity. Now write F1. F1 is how much? That is k cube. So this will be k. Remember, k q divided by r square. So minus 1 is there, divided by r square, right? Similarly, k minus 2 divided by r square. But r here will become 2 square, right? Similarly, k minus 3 divided by 3 square, right? This up to infinity. If you take, you will get that I will take minus k common from outside. So what I will get? I will get 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, right? This up to infinity. Now this you have to add. Okay, for getting f net, what you have to do? You have to add this minus k 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to infinity. How to add this? Just think about it. It is a like it is a some series. You have to tell me which series is this. Just try to add this. If you remember the series of, do you know the series of lnx? Lnx series is how much? It is 1 min, sorry, yeah, it is 1 plus x upon 2 plus x upon 3 plus x upon 4, like this up to infinity. Okay, just put the value of x equal to 1. So you will get ln 1, 1 plus, this is 1 plus 1 by 2. So it is ln 1 minus 1 is equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to infinity. So this is going to be the series. So we can write this. So this is the expansion of ln x. So our force will become, okay, our force will become minus k times of ln 1 minus 1, and ln 1 is 0, we know that. So it will become k Newton. Okay, so this is our net force. It is a application of, basically, how we have apply, like we have applied a series expansion in this type. So this type of questions can also be asked in the exam, where we have a small amount of mathematics is also involved. Now let's move to our next very important topic, that is the, from where the most of the important questions are asked. So we will start with this. It is, we are not going to read it as a topic, we are going to take it as a problem. So let us take one problem, and the problem is very simple. We have given a one rod, okay, and from rod the distance is a. There is a small charge q is there, okay, and suppose the charge on this rod is q, which is uniformly distributed. Uniformly distributed. It is uniformly distributed, and suppose the length of the rod is L. So it will have a positive plus Q charge over here, over the length. My question is, find the force on Q due to the rod. Obviously, the rod has a positive charge, so it will apply a force on the small q charge, which is kept at a distance of a, right? So as it will apply a force, so my question is that how you have to calculate the force that is going to be applied on that. So that is a question. Can we apply that direct formula here, which we have learned, that is kq by r square? Is it possible, kq1 q2 by r square? Is it possible to apply a direct formula here? Is it possible to apply a direct formula in this case? Can we apply a direct formula? Can we apply a direct formula over here? Is it possible? Anyone please let me know, like, is it possible to apply the formula over here? Okay, like see, we cannot apply the formula over here, because what the formula we have learned, k q1 q2 by r square. This is the formula we have learned, right? This formula is valid when q1 and q2 are the point charges. Then when they are point charge, okay, when they are point charge, okay, this charge is point charge, no problem. But this charge is not a point charge. It is a uniformly distributed charge over a rod. Okay, so it is not a point charge. So when it is not a point charge, we cannot apply this formula. It is not possible to apply this formula. We can't apply this formula. This formula is only, that's why it is mentioned here properly. The Coulomb's law is only valid. If you remember, I have, well, while telling this formula, I have mentioned here Q1 and Q2, and whatever the problems we have solved till now, in every problem, the charges are considered as a point charge. There is no distributed charge over the surface is there. It is always considered as a point charge. So because the Ohm's law is only valid for the point charge. Let me mention here so that it, Ohm's law, or not as a Ohm's law, you can write it as this formula is valid for the only for the point charge. Valid for point charge. Okay. So this formula we can't apply here. Then the question is that how we can calculate the force due to this rod over the charge q. So for solving this type of question, whenever there is a uniform surface is given or some type of distribution is given, we have to go and use the something called as a integration. Now from here, our integration is going to be act. Why? Because what we have to do, we have to break that rod into the smaller point charges. Why? Because see, we can only apply the formula when it is a point charge. But the problem is here, it is not as a point charge. This rod is not behaving as a point charge. We can't consider it as a point charge because it is not a point surface. It is a some surface which has some dimension. Okay. So what we have to do, we are going to divide it into a small point charges, small pieces. and then we will calculate the force due to the one small piece. Okay, and that force we are going to add it to get the total net force. That is our way of solving this question. So whenever I'm telling you this question, but afterward you have to apply the same thing for all the cases. So what we are going to do, we are going to break this rod into the small element, and then we are going to calculate the force due to that small element, and then we are going to add that force. That is our concept. So what we are going to do, so let us see here. So first we will take this rod. Okay, this is my rod, and from a distance a from the rod I have a charge q. Okay, and this length is l, right? So my approach is very simple. I will break this rod into the small element. So let's take that small element is dx. Okay, this is a small element, that is dx. I went from I went from here at a distance x. Okay, and I have taken a small element as dx. Now let us consider on this dx how much charge is there, that is dq. Okay, that is dq. Before solving that, you have to know about the few terms. Okay, that is very much going to be used in everywhere. So let me tell you this terms. First is linear charge density. Linear charge density. Just note this important densities. Linear charge density. What is linear charge density? Simply charge per unit length. Charge per unit length is called as the linear charge density. Okay, charge per unit length is known as a linear charge density. Okay, and that is defined as lambda, which is equal to q by l, or you can say dq by dl. Okay, for smaller dimensions. Similarly, we have another type of density which is called as a surface charge density. Okay, surface charge density. Now what is surface charge density? Let us learn about this. Surface charge density is, see, it is charge per unit per unit length. This is charge per unit area. Okay, charge per unit area. That is called as a surface charge density, and it is defined as sigma. That is equal to q by area, or you can say it is dq by dA. Okay, dq by dA. And third is that is volume charge density. Now what is volume charge density? Volume charge density is defined as charge per unit volume. Okay, charge per unit volume. So similarly, we will get a rho. It is represented by rho, which is equal to how much? Charge per unit volume, or you can write it as, for a smaller volume, that is dq by dv. So these are the different types of densities are there. Why I am telling you these densities? Because these densities is going to use for solving the question. So let us come here. This is a dq. I have mentioned that the charge is uniformly distributed. Okay, so I can say my lambda here is equal to what? Q by L, right? And this should be also equal to dq by dl. But what is the dl I have taken? That is dx. So this can be written as dx. So I can say my lambda is equal to dq by dx. So I can say my dq will be equal to how much from here? Lambda is equal to dq by dx. So dq will be lambda dx. So it will be lambda dx, right? So that is a I think we have got. Now, if you see this picture properly, we have converted our problem to like this. We have a small charge dq is there. Okay, this is my dq, and from here the distance is x, and we have another point charge q. Now we have to calculate the force between these two. It's a simple problem. We know what is the force. A small force df will be simply k. What is the charge? dq into q divided by x square. Okay. Now this value will be how much? K. What is dq? dq is lambda dx, right? Into q divided by x square. What is a constant? Whatever is constant, just take it outside. Okay, constant terms outside. So it will become k lambda q, and integration. You have to integrate the total force. To get the total force, this is a small force. To get the total force, we have to integrate, right, on the both the side. Now the important question is that what is the limit of integration? From where we have to integrate? That is the important thing. Is what is the limit of the integration? See, we are integrating for x. Now, what is the limit of x? X is moving from this point to this point, right? This is from x is going from here to here. So, what should be the limit of integration? What is the value of x here at this point? The value of x at this point is L plus a, right? This is L plus a. What is the value of x at this point? What is the value of x at this point? That this point, the x value is L plus a. What is the value of x at this point? The value of x at this point is L minus a, right? L minus a. So this is our limit. Now just integrate this. So when you integrate, you will get k lambda q minus 1 upon x. So you can write 1 upon L minus a minus 1 upon L plus a. Remember the integration of 1 upon x to the power n into dx, you can write it as x to the power minus n plus 1 upon minus n plus 1. This is the integration, you just remember this. Okay. Now this is thing you can solve it. How much? It can be 1 by 4 pi epsilon naught. Lambda is how much? Lambda, write it here, lambda only. So you will get 2a upon how much? This is L square minus E square. So this is the answer for this question, right? Okay, so this is what the net force which is acting on a unit charge, that is by this rod. Just note it down, and if anyone have a doubt, please let me know. Basically, you can see, let me write it again for you. Okay, see, this is the small force we have written. Now, what basically we have to do, we have to integrate this force, okay, to get the total force. So I am taking all the constant this side and variable this side. So variable is dx upon x square, right? Now we have to go for the limit of x from where the x is varying. Basically, we are integrating for the length of the this rod. So rod is starting from this point. Sorry. Rod will start from this point and it will go from here. At this point, what is the value of x? What is the value of x at this point? I'm asking at this point, what is the value of x? A. Okay, yes. The value of x is a. What is the value of x at this point? At this point, what is the value of x? At this point, what is the value of x? Yes, L plus a. So this is how now you have to simply integrate this. So this will become k lambda by k lambda q. This is integration of 1 upon x square. Integration of 1 upon x square is minus 1 by x, right? So you will put the limit, upper limit minus lower limit, right? So minus 1 upon x, and this is a upon a to l plus a. Now you just put the limit, what you will get, k lambda q 1 upon a minus 1 upon l plus a. Now from here to here, mathematics, this is math, this is not physics. You have to refer this formula, x to the power n integration dx is equal to how much, x to the power n plus 1 upon n plus 1. You should know this formula for this to do, and we have to put the upper limit minus lower limit, that I have done. So this is what you will get the final course. Okay, clear? Please let me know it is clear or not. Okay, so we will move to the next question. Let us consider next question. Okay, now you have to solve this question. Just a minute. Okay, but I will draw it. Okay, so this is basically a ring. Okay, don't look like a ring, but you can assume it. It is a ring. Okay, this is a ring. On this ring, again, we have given a charge q. Okay, it is uniformly distributed, and it is a, remember, it is a ring. It is not a sphere. Okay, it is a ring. Okay, semicircular ring. Semicircular ring means it is a half part of the ring. Okay, we have given a charge q over the ring. Okay, so obviously the charge will distribute. My question is that where the charge will come, the charge will come here, or the charge will come over the surface, like where it will come, over the length or over the this part, where the charge will be distributed. If I give the charge to the ring, then where the charge will going to be distributed, that is the question. On the on the surface, or you can say on the length. This is not a surface, because ring will have a no surface. It have only a length, so this will distribute over their length, right? It will come like this, and it is uniformly distributed. Whenever it is not mentioned what type of distribution is it, then you have to always consider it is a uniform distribution. That is a simple way of considering. Whenever it is not mentioned, just consider a uniform distribution. So here we are considering that is a uniform distribution. Other, if it is a non-uniform distribution, they will mention some type of like some type of variation they will mention. and that we will see in the end of the course, because in the end we will consider the non-uniform distribution. So it is a uniform distribution. Okay, now if it is a uniform distribution and charge q is there, my question is very simple. I at the center, this radius is r. Same question, at the center I have kept a charge q there. Okay, this is charge q which is kept here. Let me draw it properly, otherwise it will be confusing. So yeah, at the center we have a charge q. Now my question is that you have to find the f net. Simple. F net, that is my question, you have to solve. Calculate the f net. Same manner you have to do. You have to first take the element, then you have to, because you can't apply the formula here, so you have to take the element. You have to take the element. Let me tell you one more thing for your easiness, that lambda is given. Okay, here we will have a lambda. Why? Because the charge is over the length. Okay, there is no surface is there, there is no area is there, it is over the length. So you can now calculate the by take the element and calculate the what is the force on this charge q due to this ring. You have to tell me the force. You have to tell me what is the force acting on this charge q due to this ring. First tell me what you are going to do. Like how you are going to like take the element. What is the way of taking the element? How will you take the element? That is important. Will here also you will go at a distance x and take the small element dx, or what you will do in this case? You are going to take a small element dx. The important thing is that how you are taking the element. If you are taking the element in a proper way, it will make the question easy. Otherwise, it will be difficult for you to solve. So, question is that how you are going to take the element. Anyone, please let me know that how they are taking the element. Some you Rita, Samyurita, okay, Senurita. Can you tell me how you are taking the element? Yes. Can you tell me how you are taking the element? How you are going to take the element? Whether you are going to take it as dx as we have taken earlier, or it will be something else. At least tell me whether it is the same as the previous case or it is different. Anyone? Okay, no, it's not as a dx, because there is like, you can see there is no like, it's not along the line, right? It is some, it is here. It's not like this. If you see the properly, suppose at this point, then 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 this point. So what is varying from here to here as we are moving? What is the thing which is varying? Is the distance is varying? No, the distance is fixed, right? Here also distances are, here also distances are, here also distances are, here also distances. What is varying? What is the thing which is varying? Which thing is, which part is varying in this question? Which is varying? Which thing is varying? Just try to see at this point, this is the case. At this point, this is the case. At this point, this is the case. So distance is same only, right? Which part is, what is varying from here to here? As we are moving from this point to this point, what is the part that is varying from that, from as we are moving? Anyone? As we are moving, which part is varying? Charge is not varying. Charge is obviously how the charge will be. Charge is, as we are moving from here, just try to see, we are going from here to here, right? Here to here. Which, what is the variable parameter from here to here? Yes, angle. angle. As we are moving from here to here, you can see the angle is varying. Angle is going from 0 degree to pi degree, 180 degree. As we are moving, we are going from 0 to 180 degree. So the angle is moving. So angle is changing. So in this case, how we take the element? We will go from a small angle theta, okay? And we will take a small element of d theta. This small element as d theta. And this is the small, our small element, right? Let is named as some length of this element is dx, okay? Don't confuse with this dx is same as the previous ds. No, it is different. Now can you tell me this distance is r, right? So can you tell me what is dx? Dx I can write it as, you know, arc is equal to, what is arc length? Arc length is equal to radius into theta. That is a formula we know. So you can write that dx is equal to r d theta, right? The angle is, small angle is d theta, radius is r, so dx is r d theta. Now if you see properly, now it is become like this. Now the question is became like this. Suppose this is my axis, okay? You can see there is a point charge q is there, and we have a charge, another q is there here. This is a dq charge, okay, which is given as lambda dx, right, previously, and this is written as lambda r d theta, right? So this is the thing. Now you have to simply calculate the force. So you can see properly, these are the case. Now this charge is going to repel this charge in this direction, right? Because they are both are the same type of charges, if they will repel each other. Suppose this angle is theta, okay? So then here we will get a one component called, suppose this force is df, so this will be df cos theta, right? And this will be df sin theta, right? So we will have a two components. Now we will integrate these two and to get the net force, okay? So let's take this horizontal one, okay? So first we have to write df. So let us first write df. What is df? Df is a small force, okay? That is a force between these two charges, that is k q dq. What is dq? Dq is lambda r d theta. So this will be lambda r d theta divided by, what is the distance? The distance between these 2 points is r only. This charge and this charge, this is r only, so this is r square. So when you cancel out this r and r, what you will get finally? Q sorry k q lambda divided by r into d theta, right? This is the finally we are getting. Now you just put the value. Now first we will take the horizontal, f horizontal, that is equal to how much? Df cos theta, okay? To calculate the net force we have to integrate this, right? Now what is this will value? You put it k q lambda upon r into d theta into cos theta. Now my question is that, what is the limit of theta? From where the theta is varying? From what is going to be the limit of theta? What is the limit of theta in this case? What is the limit of theta? Sarvanan, what is going to be the limit of theta here? From where the theta is varying, from which point to the which point? Sarvanan, what is going to be the limit of theta? Anyone else? What is going to be the limit of theta from where the theta is varying? From which point to the which point? 0 to 180 degree. Yes. The theta is varying from 0 degree to 180 degree. That is pi. Now just Integrate this. Integration of cos theta is, what is the integration of cos theta? Sin theta, right? So this will become k q lambda by r sin theta. Now the limit is from 0 to pi. What is sin pi? That is 0. Sin 0 is 0. So this value will come out to be 0. Means there is a no force in the horizontal direction. In horizontal direction, you won't get any force. Now let us do the integration for vertical direction, perpendicular direction. This will be integration df sin theta, right? Df is how much? Kq lambda by r into sin theta d theta, and we have to integrate from 0 to pi. My question is that what is the integration of sin theta? The integration of sin theta is how much? How much is the integration of sin theta? Integration of sin theta is minus cos theta, right? So kq lambda by r into minus cos theta. Now limit is from 0 to pi. So when you put the value from 0 to pi, what is the value you will get? You will put the limit, you will get 2k q upon lambda into r. Now this force is coming in downward direction. So we can write it as minus j cap. So that is our net force. So what is the net force here? So net force is simply given as the 2k lambda q by r minus j cap. That is a answer. If you can see, analyze this thing, I have no need to calculate this horizontal component. I can intuitively, I can say that this horizontal component will already be zero, because see, I have taken the element in this direction. I am getting f horizontal force in this direction and vertical force downward. Okay, now let us take the component in this direction. If you take the component from this direction, you will get a horizontal force in this direction and vertical force in downward direction. So these two horizontal forces are getting cancel out each other. That's why we are getting the net force is zero in this case. And obviously you can see that this is the charges, right? And this is the point charge. So the charges are upward and there is a point charge. So they will try to pull downward only. Na? They will try to repel in this direction only. There will be no repulsion in this direction will come. So that's why we are getting the net force. If someone asks me, okay, if someone asks me like tell me the direction of the force, I have no need to do all this calculation. I can just tell that okay, these charges are there, this point q is there, so they will try to repel in the downward direction. So the net force will be always come in the downward direction. There will be no force in the horizontal direction. So I can directly write this horizontal force will be zero. But just for your like, just for the safety, I have told you that this will be zero. By you can calculate also, but now further we will not going to do this calculation. We can directly tell okay, the net force will be zero only. There is no need to do the calculation in this case. Okay, let us take one more example. In this case, uh, let us take one more question. Let us make it slight complicated so that they can get more practice. Suppose I have a quarter ring, a quarter of the circle. Let me draw it properly. Okay, suppose it is a quarter. Okay, a small quarter, and I have given a charge q over this, and there is a one charge q is placed here. Now my question is again same. You have to calculate the f net. What is the net force? Everything is same as I have mentioned. This is q, lambda is given. Okay, lambda is given, whatever. Now you have to again take the element and you have to calculate and tell me what is the net force on this charge q. Okay, just try to do it. And radius is r. Okay, you can assume radius is r. Now you tell me that, first tell me whether the horizontal force in this case will be zero or not. Like in the previous case, as we can see here in this example, the horizontal force is coming zero, right? We are getting only like force in the vertical direction. Now in this case, is the horizontal force is again zero, or it is non-zero? Just try to think, try to analyze whether the horizontal force in this case is again zero or it is non-zero. Is it zero or non-zero? Okay, non-zero, right? So it is non-zero. That means you have to calculate the horizontal force also, vertical force also, and then you have to take the summation of this. Then you will get the net force. Just try to do it. It is same. You have to take the, now you have to take the, again you have to save the, take the same element, do the same thing, calculate the F horizontal, F vertical. Just try to do it within 2 3 minutes and tell me the answer. What is the value of F net in this case? Sorry. See, I'm giving you this as a homework. You can do it. It's the same question. Okay, this is as a homework. We will check it tomorrow. You will get F net. I will tell you the answer. Okay, no, I will tell you answer tomorrow. Uh, if I tell, you will try to bring it at anyway. Okay, so just take it as a homework. We will discuss this tomorrow. Yesterday, sorry, tomorrow. Now let us start with a very important topic, that is equilibrium of charges of charge. Equilibrium of charge. What is the meaning of equilibrium of charge? Let us understand with a one example. Okay. Let us consider this is a charge Q is there. There is a 4Q charge is there. Okay. My question is that where should capital Q, this is Q, this is 4Q. My question is that where should capital Q have to be placed to get F net equal to 0? Means, or you can say Q in equilibrium. Means my question is very simple. I have a charge capital Q. Okay, I want to place this capital charge Q on somewhere. Okay, so that the force on that capital Q charge should be 0. That is my question. So how, where we will place it? My question is that where we are going to place it. Suppose the distance between these two charges is L. Okay. My question is that where we are going to place that capital Q charge. Whether we will place here, we will place here, we will place here, we will place here, we will place here. Where we have to place it so that our net force on that capital Q is going to be 0. That is our question. So what is like? First, you tell me like how to think for this type of question. How do we have to think that where should we have to place? First, tell me one thing, that is it possible, can I place the charge here or here or here or here, the net force will be, the charge force will be 0? Is it possible? Is it possible if I place the charge anywhere, not on the line, not on this line, anywhere other than this line, is the net force will be 0? It that is that charge will be in equilibrium if I place other than that line joining the centers, other than line joining the centers, will the force will be 0? if I place the charge, okay, if I place the charge other than this line, will the force will be zero? Will there will be the case that force will be zero? No. Why? Why the force cannot be zero if I place other than this line? Other than the line joining the center, if I place the charge, why the net force cannot be equal to zero? Why it is not? Why it is not possible? Why it is not possible? Why we cannot make the net force zero if we are placing other than that line? Other than that line, if we are placing, we are not getting a net force zero. What is the reason for this? Let us consider. Suppose you have placed here. Okay, this will apply a force in this direction. This charge will apply the force in same direction. So two forces are in the same direction. Can they never can is there is any possibility that they can equal to zero? Suppose there is a block. I am applying the forces in the same direction. Is it possible the net force on the block can become zero? Suppose there is a block. I am applying a force here. Both the forces are in same direction. Will this block have a net force equal to zero? Is it possible? Is it possible? No, is it not? It is not possible. The net force cannot be zero, right? Because we are applying the both the forces in same direction. So they will be add up together, right? So add up together, they will increase the value. The value will be increased. It will not decrease. So net force cannot be zero. There is no possibility. So that is why I told you you can't place. You have to place along the line joining only. You can't place anywhere else. Now, in the line joining, if you will see, there are the three possibilities are there. What are those possibilities? Possibility number one, that is here. I can place within this place. I can place here. I can place here. There is a three possibilities are there. If I see, there are three possibilities. So let us consider first possibility. Suppose I place here. Suppose I place here. Okay. This is the first case. If I place here, this small q will apply the force in this direction, right? That is a force in this direction. This 4q will also apply the force in this direction. So is it possible to get the net force on this charge if I place here 0? Is it possible? Can we make the net force 0 in the when we are placing the charge in this at this position? Is it possible? Answer fast. Like you can tell fast. Is it possible to get the net force 0 in this place? No, obviously it is not possible because the both the force are in the same direction. Similarly, you can check for here also. Suppose I put here this 4q we apply the force in this direction. This q will also apply in this direction. Again, it is not possible in this case also. In both the case, so what we can see that in both here also not possible, here also not possible, means we can't place it here also. So what is the two cases we got? We cannot place the charge anywhere else. Okay, we cannot place here also, here also. So where we can place it? So only one place is left, that is this place. So let us check for this place, is there is any possibility. So if I place the charge at this point, suppose, okay, this 4q will apply the force in this direction, right? This q will apply the force in this direction. Yes, the forces are opposite. So there is a possibility that this charge can have a net force 0 because two forces are there. They are acting in an opposite direction. So there is a possibility that this force and this force will cancel out each other. So that means it can become 0. So let us that means there is only one possibility which has to be placed in this position. So let us consider this is my q and this is my 4q, and I got that it has to be placed somewhere here. I don't know the position. Let us consider that this position is x. So what is this distance? The total distance is L, right? So this will become L minus x. Now this will apply a force F1 in this direction, F2 in this direction. So F1 should be equal to F2, right? If they have to cancel out each other, if I want to cancel these two forces, then it should be same, right? So F1 should be equal to F2. Now what is F1? Sorry, K Q, capital Q by X square. And what is F2? K Q 4Q upon L minus X square, right? Is I am correct? Yes. So they see this, everything will be cancel out. You will get L minus X is equal to 2x, and L minus X is equal to 1 minus 2x also, right? So from here you will get L is equal to how much? 3x. So X is equal to how much? L by 3. Now from here if you calculate, what you will get? L is equal to, see this is, you will get minus X. So X is equal to minus L. What do you mean by minus L? Minus L, see we have taken X in this direction, right? Sorry, we have taken X in this direction. Minus X means in this direction, right? We have taken X in this direction, so minus X means in this direction. So as we can see that we have initially only told that the charge should be placed in between this, okay, in between this. So that means this X will be always less than L, obviously, because if it is placed between this, X cannot be greater than L, because it has to be placed between these two charges. So X will be always less than L, okay. There is that is X will be always less than, because it is placed in between, right? So obviously this answer will be rejected. This is the only correct option. So what is our position? So our position will be like this. So finally, if you understand what is the conclusion we got, if this charge is Q, okay, and this charge is 4Q, so I have to place the charge at Q, capital Q, at a distance of L by 3, and this distance will be how much? 2L by 3. So this is the configuration, final configuration, so that the force F on this charge will be 0. F net on this charge will be 0. Is it clear to everyone that how to calculate, how to give a approach to this type of question, right? Is it clear? Please everyone tell, is it clear or not? I'm not asking only one person. Everyone should answer. Is it clear? Okay. So what is the conclusion we have to obtain? Like we can't take that much time to calculate, right? We have to give some conclusion so that our calculation will be little easier. So there is a one conclusion we have got, and we will note it down, and this we will going to use it. Okay. So what is the conclusion? Let me write it, and you can use this conclusion everywhere. Okay. The charge should be placed in between two charges for equilibrium when the charges of same nature. This you can say is as a trick or whatever you can say. This is the like basic conclusion we have obtained. If we have a two charges, okay, and they are of same nature. Same nature means, see, you can see this is also positive, this is also positive. If this is negative, this has to be negative. That is the first thing. So it should be, if there are the two charges and they are of same nature, then our third charge should be placed in between the two charges to get the charge into the equilibrium. And how to calculate that distance, that we know from this basic calculation, we can calculate the distance also. So this is a first approach, first conclusion we have drawn. Now the next question arises, okay, if it is of same nature we got this, but suppose if it is of different nature, different nature means if this is positive, this is negative, that can also be a possibility. So let us understand this possibility, that how to calculate for this case. So let I am taking the same example. Okay, suppose this charge is q and suppose this distance, but now this time this I am making as minus 4q. Now the nature is different, and again I have a same question, where should q is placed to get the f net is equal to 0. Simple question. Now you have to tell me where I have to place the capital charge Q to get F net equal to 0, or you can say the charge should be in equilibrium. Where that, again same thing, we one thing we are sure, we cannot place anywhere, we have to always place along the line. Now you have to tell me whether I have to place here. I am giving the numbering, you have to tell me 2 or 3. At which position you have to place? 1, 2, or 3? Which position I should place the charge? Just answer me. Which position I should place it? Whether I should place at position number 1, position 2, or position 3? At which position? Which position the charge has to be placed to get the net force equal to 0? Position number 1, position number 2, position number 3. Just test, put the charge and try to test where the net force is coming 0. Obviously that will be the position. Just try to check and tell me which position should place the charge to get the net force equal to 0. Where should I place the charge? Simple, you have to use the concept. Simply you have to test where the force is 0, where the force is not 0. Which position I should place it? Whether it should be position number 1, 2, or 3. Which position? Which position I should place the charge? Position number 1, 2, or 3? You are asking me question. I am asking you a question. You are asking me question. 3 position. I am asking you which position. You tell me position. 1, 2, or 3. Position number 1. Okay. Who is saying position number 1? Sarvan. Okay. Who is saying, how many of you saying position number 2? Who is saying position number 2? Okay, so let's see. First of all, the person who is saying position number 1, I don't know how he is saying. Just let us keep the charge at position number 1 and test. Suppose if you keep at position number 1, this charge will repel in this direction and this charge will attract in this direction. How is it possible to get net force equal to 0? Both the forces are in same direction, right? So how the position number 1 can be possible? Is it there is any possibility that position number 1 can force will become 0? Obviously not, because both the forces are in same direction. So force can never become 0, right? If the both the forces, that means position number 1 is not possible in this case. Okay, this is not possible. Now it's come to position number 2 and position number 3. Let us check for position number 3 first. because one person has told position number 3. So let us check. Suppose if I place position number, suppose I am placing at position number 3. Okay, I am placing at position number 3. Then what will happen? This charge will attract in this direction, but this charge will repel in this direction, right? This is the case. This charge is going to attract in this direction. There can be possibility that this force will become zero. You may think, okay sir, I am placing the charge here, this charge is attracting in this direction and this charge is repelling in this direction, it's repel the charge in this direction. You may think that the force at this point will become zero, f net will become zero, you may think, but it is wrong. Here force can never become zero. Why? The reason is very simple. If you see, this charge is bigger than this charge, right? So the effect of this charge will be more. It's a 4 times of this effect of this charge will be more. And if the effect of this force will be more than this F1 and this is F2, so F1 will be more than F2. So we can't place the charge at this point also. Okay, there will be always a only one position. So who is asking that is position number 3 is possible? Answer is no, it is not possible. The reason is very clear, because this is more closer to minus 4q, so which has more dominance over the force due to the charge q, so obviously it will try to attract it. So here there is no possibility that force can become zero, so you can't place at position number 3 also. So only one position is left, that is, and you can also put the charge and you can test also, you won't get any value of x that will satisfy this. Okay, you can put it also, or you can check, you won't get any value. So only one position is left, that is position number 2. So that is the only position we can keep the charge, and we can keep the charge at some distance, suppose x. Okay, and now if you test also, you will get the force F1 here, F2 here. Okay, and for net force has to be 0, F1 should be F2 equal to F2. Now write F1 will be how much? K small q capital Q. What is the distance? X square, right? And this is equal to K Q capital 4Q divided by, what is the distance? L plus X square whole square. So you will get something called L plus X is equal to 2x and L plus X is equal to minus 2x. Okay. So from here, if you calculate, you will get X is equal to L, and from here you will calculate X, how much you will get? You will get X is equal to minus L by 3. Again, first thing, here we are keeping outside, right? Here we are keeping outside. One thing is very clear, I am taking X in this direction as positive, right? In this direction, I have taken X in this direction, so my this direction is positive. Minus X means my this direction will, my it is coming in this direction, and I have told you the charge should be always placed here, so obviously this answer will be rejected, because it is saying the charge should be placed here, and here we have seen that force can never become zero, so this option will be rejected. So we will get X is equal to L. So what is the final configuration we will get? The configuration is like this. This is Q, this is this is minus 4Q, and the distance is L, and from again at a distance of L we have to keep our capital charge Q, and this is our final configuration for F net equal to 0, right? Is it clear, like how to solve this case? Is it clear to everyone? Is it clear to everyone? Is it clear to everyone? Okay, so this is how we have to calculate. So what is the conclusion we have got finally for this case also? Wait, just give me 1 minute. Okay. Okay. So what is the final conclusion? What we have to remember? The conclusion is very simple. The charge should be placed closer to the smaller magnitude magnitude charge on the other side, not in the between. Okay, on the other side, when charges are of different nature. Clear? So this is our conclusion for this. Where should we have to place the charge? The charge should be placed on the, okay, the charge should be placed closer to the smaller charge. You can see we are placing it closer to the smaller charge, that is a small q. In the case of magnitude, do not consider sign. Okay, you have to consider magnitude should be placed on the closer to the smaller magnitude charge on the other side, not in between. On the other side it has to be placed. Okay, when the charges are of different nature, when both the charges are going to be of different nature, it has to be placed like that. Clear? Is it clear to everyone? Is it clear to everyone? Is it clear to everyone? Okay. Why less number of people have joined the session? What about the other person? What about the other person? Like why they haven't joined? You have got the notice, right? Everyone has got the notice regarding the class. See, from I will let you one thing know. From today onwards, regularly, if you are not clear with the timetable, let me tell you one thing. How's your timetable is going to be, so that you will be very clear regarding it. See, regularly, if you are not sure, just take the screenshot of this. Okay, regularly. Okay, you have a class from 5:30 to 7 morning. Okay, as well as evening also, 5:30 to 7 evening. We have two sessions. Okay, morning and evening. In morning we will cover physics. Okay, and in evening we will start with chemistry. Okay, this is going to be this thing. 3 days we will have a class 11 physics, 3 days we will have a class 12 physics. Okay, so this is going to be the like timetable which is going to be followed from today onwards. So today you have another session at evening also, that is 5:30 to 7. Okay, so just ask your all friends to join. Okay, like otherwise they will, when they will come, they will not able to cover the things properly. Okay, so where we are? Yes. So this is the conclusion we have got. So if I ask you one thing, okay, let's take one example. Okay, it's a good question. You can like try to solve it. Suppose there is a charge Q is there, and suppose the distance is okay 2L, or okay, let L, and suppose this is 16Q. 16Q. I want to place a charge Q. Okay, so that total F net is 0. Total system, I can say better to be total system is in equilibrium. Total system is in equilibrium. Okay, and I also know the value of Q. What should be the value of Q? Initially, we are only considering the distance, right? Now, my one question is more I have added. What is the value of Q? What is the value of Q we have to consider so that it should be? Okay, I will give it as